Hello, everyone, and welcome to this webinar. My name is William. I'm one of the co-founders of NannyML, and today I have with me Nico Verheijden from Deleuze. Nico is a very good friend of mine, and we've been working together on demand forecasting and model monitoring for quite some time already. He will introduce himself shortly after, but maybe I'll lay out a quick agenda for today. So Nico is going to present from his perspective the demand forecasting use case that they have been working on, and kind of set the stage for some of the post-deployment issues that come along with putting models into the real world. And then after that, I will discuss a little bit how we can address some of these post-deployment data science issues in general, and then also specifically with NannyML. And if there's some time left, I will also quickly show how to do that exactly in our monitoring platform. But that's it for my introduction. Nico, take it away.
Thank you very much, William. I will share my screen. All right. You see my screen, William? Should be okay?
Yeah, we
All
see
right.
it.
So everybody, as William mentioned, I will share a bit my experience on demand forecasting for retail, on who is on what it is, demand forecasting, why it's important, and some challenges that I want to share when we are doing demand forecasting within the company. But first of all, I present myself. Who am I? So I'm Nico Verheijden. Been working 20 years already. Did a master in computer science. I've been working 8 years now in AI. Did also a master in AI. I think 9 years ago, because I was triggered with the possibilities of AI. I always say I'm a bit lazy, so if I can automate something, then I will try to do it. And AI was there a good way to automate more and more in the future. I've been now 4 years at Deleuze. Before I was mainly working consultancy, IT consultancy, then AI consultancy. But I wanted to be a bit more strategic focused, and I thought internal in a big company it would make more sense to have that bit more long-term view on how to position AI within a company. And currently 3 years as a data science manager. I started as a data scientist at Deleuze, but then the role of data science manager was created because we need to have a bit more structure in the way of doing AI at Deleuze. So that's my current role. So what do I do then exactly as my role as data science manager? So first of all, I'm a team manager of 10 data scientists, 2 MLOps engineers currently in the team. I don't focus really on on what they are working. We have product teams where we have different types of people. So the product teams will define what the data scientists will be working on, ops engineers. But I focus more on how to do AI within the labs, which means from a technical point of view, we set up a whole MLOps framework. We are doing innovation with the business, identifying proof concepts, rolling them out, and showing the value of AI. Also educating the labs on AI, providing trainings, doing workshops with them, and also strategy, how to position AI within the labs, where we should focus on, what are our core competencies that we should have within our company moving forward, and knowing how AI is evolving. So now that you know me, now let's focus why we are here. Demand forecasting. As already mentioned, what I want to say, what is demand forecasting? So that we have a bit a similar understanding what I mean with demand forecasting. Then I'm going to quickly say something about demand forecasting and retail. Why is this so important for retail? And then I'm going to share some challenges that I had throughout my experience of demand forecasting. So what is demand forecasting? As always say, as I put here, the process of making future estimations in relation to customer demand of our products over a specific time. So what we try to do here, we try to predict what the customer would want to buy, when and where. And that can be short term, tomorrow, but it can also be long term. What will they want to buy next year? Um, and it can be on different levels, can be different level of a product. That can be on the level of a palette. That can be on the level of a category. That can be also on the level of a certain promo that you do, and that you then want to do the customer demand. So all these kind of things is the demand forecasting. If I then go to the next step, how do we position it in retail, and why is it so important for retail? Um, I think, as I put here, a simple view of our supply chain. We have the supplier who's making the products. We have the DCs. The supplier sends the products to DCs. DC will then send the products to the stores and the dark store, which is our e-commerce store. And our dark store, e-commerce store, will send then the products to the customer homes. This is a simple supply chain, but customer demand is key for knowing the customer demand is key for a supply chain. If you go then to the supply chain at the supplier side, you want to forecast what the DCs will order in the future because you need to produce enough. And that short term, what I'm going to produce today, knowing what I need to deliver tomorrow. But it's also long term. If you like a croissant on a Sunday morning, we need to know the demand next year of the croissants because the wheat is growing in the summer, so you already know to get your source material, how many croissants will I sell next year, so that I can order enough wheat from the farmer, ensuring that I can produce enough for the demand that I might have. And then also on the DC side, they're gonna start forecasting on the store level. The physical stores, they will also need to order on the DC side. So the DC will just try to predict what will the stores request to us, because I need to have enough in stock. I need to have enough people to manage the stock. I need to have enough trucks to deliver to the stores, and enough people to drive those trucks. To meet the demand. And then also on the physical store and dark store level, they're also they do the forecasting because they need to know how much do they need to order from the DC, how many people do they have in store to manage the incoming trucks, to manage the outgoing demand of the customer. Yeah. And you see, they're all forecasting what will be bought by the customer, and we're all forecasting the same thing. We're all forecasting the customer demand, as I mentioned, on a different level, on a different timeline, but we're all forecasting the same thing. And that's why demand forecasting is so key for us, especially now. I work at the LAS. What is the LAS these days? We sold all our stores, so our focus is really delivering the goods on time to our stores. So supply chain is really key for us, and thus also demand forecasting. It's not only supply chain, it's the whole organization that really can be optimized with a good demand forecasting. As already mentioned, supply chain, production planning, when do I need to produce what, replenishment, how many things do I need to have in my stock, ensuring that I meet the customer demand. It's about capacity planning. When do I need to put people where, how many trucks do I need? Do I need to buy a new truck in the future? Do I need to expand my warehouse even in the future? Delivery flow smoothing, that's optimization of your resources throughout your supply chain. Inventory allocation, so what inventory do I need to put where at what point in time? And of course, the whole strategy, how to optimize the supply chain moving forward, knowing what the customer demand will be in the future. Also on the commerce side, so what is the promo strategy? What promos do I need to do when to optimize my revenue? And that what we are now also providing to the commerce team is, okay, you do a promo, what will be the uplift of that promo, so they can really see, okay, what's is the best promo to do when, knowing what the impact of the customer demand will be if they do a promo. Similar for price setting, what is the impact of changing the price on the customer demand? And then also assortment planning, what is the assortment that I need to have in my store, knowing what the customer wants in the future. And the last topic is, of course, marketing. How do I need to position the brand of Deleuze? What products do I need to market? Also, they're based on the customer demand. If you know that people will start buying barbecue products when the weather is nice, yeah, then of course marketing can use that to work on their marketing strategy. Yeah. And so what you see here is conclusion is it's key really demand forecasting for the whole for retail because it can improve and optimize a lot of business processes. I have a certain vision also of demand forecasting. First of all, I think there should be a central forecasting team within the company. As I mentioned, we're all forecasting the same thing, so that forecasting knowledge is similar for each forecast that we provide. We can do cost optimization by sharing a lot of resources. We can do consistent forecasting with that central forecasting team, aligning the forecast on the different levels. If you do forecast in the store and you forecast in DC, how much the store will want to order, yeah, you need to align those forecasts because otherwise you create already inefficiencies in your supply chain uh, before even delivering anything. Similar tools and processes, also cost optimization, and also central data sets for all models. If each person is doing their forecasting separately, probably has their different data models. We all need weather data. They probably have then different weather data. So that's why I think we should have a central forecasting team. Also, it should be an in-house competency. As I mentioned, it is key for retail. So I also think we should do it in-house to create a competitive advantage. If we're always doing the same forecasting with all the retail, yeah, then we are only as good as everybody else. But if we can even do a percentage better than another retailer, we can really create a lot of cost saving and really create that competitive advantage. I see I had some text here that was not correct. All forecasting models could be challenged, so it's about continuously improving also our model. So we should be able to challenge, even if there's an external supplier, I should be able to challenge it because, as I mentioned, it's important that we can keep improving it. And also, it should be local. As I mentioned, I work for the LAS. It's part of the Ahold group. I was also thinking, should we not do it on a European level, maybe? But what I see now, based on the experience that I have, you really need to sit next to the forecast because it's not only about providing a forecast, it's also about understanding how the forecast is used because it's always an input for a certain business process, and how it's used is key for how to provide a forecast. So I explained a bit what it is forecasting, explained it how important it is and how I think we should position it within the company. I'll share now some challenges that I had out of my experience. First of all, data understanding is business understanding. Have here the garbage in, garbage out picture that everybody knows. And data quality is of course key, and that's I think a challenge for all data science projects. But what I see here is that you think, okay, you at customer demand, we don't do it, for example, for e-commerce demand forecasting. Yeah, you think, yeah, they just deliver goods to the customers, and you do a promo, there's an uplift. But what I saw is that it's always more complicated, and the business lets it shine out. And also, yeah, we talked to the operations team of e-commerce, but promos are an important driver of the demand forecast, but we're not always talking to the promo team. By analyzing then the data, we saw, for example, you assume you have a promo on a product, that there is only one promo per week on a product in one store. But that's what's, and if you ask, that's true. But what we see in the data that we sometimes have two promos on one product per week. What is it happening? We have American promos. So that means if you buy more of that product, you get a higher percentage discount on that product. So these kind of things, by really trying to understand the data, you get also more understanding of the business, and that's important because that's also it's how you model your how you need to model the data for your forecasting. For example, those two promos, yeah, we cannot have two promos. So how do you model that in your forecasting algorithm? So these kind of things are really key when doing the forecasting. Another thing is, yeah, build the trust. Forecasting is an operational insight, so it will be used on a daily, weekly basis as an input for a process. And now we do it for replenishment for e-commerce. Every day we give a forecast and is used as an input on, okay, how much do I need to order in the DC so I have enough in stock to meet the customer demand for next week for e-commerce. But it's really key because if it's too much, you create shrink. Shrink is the things that you need to throw away if they go bad and they're too long in the warehouse, or it's not available and you're losing sales. So even a bad forecast can quickly create a big issues. And as it's an operational, yeah, the business has no time to check it, verify it. It's everyday input. It needs to go fast. So it's really how do we build the trust with the business that they really start thinking, okay, this is something that I want to start using. I see the value and I trust that every day that forecast will be within within the expectations that I have of the quality of the performance. And so that's really building that trust, and that's going to the business and really understanding the business. And you need to start talking the language of the business. Why do you need to forecast? Because it's important that we know. A good example here is, yeah, okay, for e-commerce, we want to impact shrink and availability. But okay, what do you want? Maybe it's better to over forecast or is it better to under forecast? And even there, the answer is not easy. It's depends on what product, because for some products you need to have them in the assortment, otherwise you lose customers. If you go to the store, everybody buys eggs almost every time they go to the store. If you don't have eggs, they will go to a competitor because you did not find eggs and you lose a customer. But for other products, more expensive, like expensive meats that's fresh, that can only be in the DC for 2 days, yeah, there maybe you prefer to be under forecasting because it's very expensive to throw away, and maybe the person that is then shopping will not leave, but they will more like be a bit disappointed. But you can maybe provide an alternative product then that is very similar. So that's why I talk a lot about it, but it's really that business understanding that's key, but then also give you the possibility to provide the best forecast for them and really building that trust. And it's also about, okay, the business KPIs and how you measure them, because at the end you also want to align your forecast with the business KPIs. I'm doing a good forecast, I have a good business KPI, I do a bad forecast, what is the impact there? Because that's how you show also the value and build that trust with the business. On the other side, you also need to educate a bit the business on what you will do, because the more they understand what you're doing, the more they trust on what you're doing. So it's about what you will provide, how you need to agree with them. Okay, we're gonna test it like this. Do you think it's a good way of testing? Do you trust this, that we do this? And this is how we will measure the performance. They need to understand what it means. Everybody wants a MAPE, but that's always not the best approach. So you need to really guide them in that process, that they understand it, that you align with them on how you will measure it and really build that trust. And then the next phase is also keep the trust. So once there is the trust and they say, okay, I want to start using it, we can industrialize it, put it on a production. Yeah, don't just put it on production and see what happens. No, set up a rollout plan, ease into it, build the trust, keep the trust. So you see, put in production, take a small scope with maybe a low risk and put in production, because also even if you put in production, there's always something that might go wrong, because something that's because you put in a production system, the data integration might be a bit different. So there, it's really key to set up a rollout plan. You can, I think we took 6 months to roll it out, which was pretty quick, even. But I think for other retailers, I think they did a year just to do the rollout plan for the demand forecasting. Also, provide a long hypercare period. It's really key that you are there full time available for any questions they have, because you see there's an impact on the availability, on the shrink. They come to you, how was the forecast? Was it good? Was it not good? Why was it not good? 99% of the cases, it's always because there was an issue with the data, or there was an issue with even with the supply chain that had an impact on it, and that is also impacting our data. So these kind of things, but you need to be there for the questions, because otherwise, if you're not there for the questions, they will lose the trust, and once you lose the trust, then it's very hard to rebuild it. And then the last step here is continuous monitoring. Huh? That's key. It's an operational insight. You deliver it every day. You need to continuously monitor what you are delivering to the business. And I have another slide on this. What do you want to monitor? Two things. First of all, am I providing a forecast? And that's really, is infra monitoring? Is my server running? Is my hard disk not getting full? And that's we have for the infra team. It's application monitoring. Is it still running? Is it an application error? That's important. But even if everything is running, you are giving the forecast. What is also key, and that's a bit the vague area, can I trust the forecast? Every day I provide a forecast. Can I trust it? And that's for me really, it's difficult, of course, but can I trust the forecasts? Because there's a lot of things. And for me, it's not about data drift, concept drift, because even if there's some data drift, my model is still performing well. And I want to have something in production that's continuously running, that I don't need to check. I need to just trust that everything is going well, but I also only want to be notified when there might be an issue. And that's why an ML monitoring tool is key, and also an ML monitoring tool that just only notifies you when there might be a risk of a bad forecast, and not when there is an issue on the data or the concept drift. So this is a bit what I want to talk about. I don't know if there any questions for me, and otherwise I give the word
Yes,
to you, of course, William.
yes. Someone has asked the question.
Yes,
Um,
I see it in the
Rishita,
chat.
if I pronounce it correctly, so I'll just ask it to you, Nico.
Yeah, go
What's the
ahead.
best parameter to measure performance of a model? Because you mentioned in the presentation MAPE, which is the mean absolute percentage error. Is that
Yeah,
your go-to metric?
I always use mean average error, root mean squared error. I mean average error because I think that's E, root mean squared error, to have a bit more vision on the big errors, and then also the bias, because it's also a business. The business always asks, do I tend to over forecast or under forecast? Because for each business process, it's a bit different. So the bias is also important for the thing. And we also use a MAPE, but we use the MAPE then. So we use, because they wanted the MAPE on the product level, they want the MAPE in for all the products. So what I do, I calculate the errors on all the products, and then I do the MAPE on that. So I don't do the MAPE on each product separately and then take the average there, but I take the MAPE on the total of the forecast versus the total of the actuals, and do MAPE there. Because it makes a bit more sense, and at least there is some MAPE metric for the business to have.
Okay, I'm also going to answer this question, but I'll answer it after maybe I've done my presentation, and then I'll revisit this one.
You
Let me
don't agree with me,
quickly.
William, maybe? Or...
No, I do agree with you. I do agree with you. I just think that I have something to add, but I
Yeah,
think it might be explained inside of my presentation, and you also already touched upon it during your presentation as well.
all right.
So let me quickly share my screen here. I'm hijacking you, Nico.
No problem.
So what I will be talking about is the post-deployment data science part, and Nico made a nice segue into continuous monitoring and why it's so necessary to build trust in the data science team. What I'm gonna do is how I'm structuring it is I'm gonna add lots of problems to what Nico had already said which is a complex use case as a demand forecasting. But of course, as soon as this model is ready and it goes into production and it gets deployed into the real world, there's lots of things that can go wrong. So I'll focus on adding problems to the already existing complexity, and then I will try to explain on how some of these problems can be remediated, and how we specifically with NannyML help with that. And I always start to the people that are already familiar with NannyML. I always start with this research from MIT and Harvard that got published, I think, a year and a half ago, that post-deployment data science is hard. And what makes it so hard is that AI models, they fail, and it's a natural process. And what they did is basically in their research, they analyzed 20,000 data sets where they deployed a machine learning model and then kind of followed that machine learning model for 1 to 3 years. And what they realized, and this was models across industries and for various different types of machine learning problems and various types of different algorithms as well. And what they realized is that 91% of those AI models, they fail in time. And an AI model is expected to decline in performance by 20% in the first year. And this is kind of what we as data scientists have to deal with in production. And this is just a given. This is just what's going to happen. And they called this inside of their paper, they called it AI aging, which is basically the age of an AI model difference when it's deployed and the moment it's making predictions. Now, why is this important for us? That makes being a data science leader also hard. Why? Because there's lots at stake. And if we don't anticipate this model failure, or it just happens and we can't really explain it, there is, first of all, reduced trust. And specifically also what Nico mentioned for demand forecasting, it's feeding in a lot of other business processes with a lot of other business stakeholders. And if they figure it out before us, then that is, of course, for sure going to have an impact. Then there's increased workloads, because for essential business critical use cases, it's important that we figure out as fast as possible what went wrong so that we can fix it. And as long as the issue is persistent and the demand forecasting models are not up to par, we're of course missing out, we're losing money. Maybe there's stock out, maybe there's shrink or stock over, what Nico said, and we'll have to throw products away. And that is, of course, money that we would like to spend otherwise. And this is kind of, in general, the problem with models in production. But then, of course, there is this traditional way of doing monitoring, and I'll first explain what it is and why it doesn't necessarily help. And this traditional way of monitoring is looking at data drift or model inputs, and sometimes also model outputs. And it's a data-centric model monitoring in the sense that when we look at the data drift or changes in the data and there's data drift happening, we send an alert. And just for a quick explanation, data drift monitoring or the traditional monitoring focuses often on covariate shift. And covariate shift is just the distribution of the model inputs changing. So if we have a certain period, maybe during testing or training, that we have a model, and we look, for instance, here at the demand of the previous months as a feature, and then we look at the next period, and we would look at the demand of the previous period, we could see that there is a change in the distribution. So here for this one, it would be different, and those are changes in the data. But it doesn't necessarily mean that there's changes in the data that the model actually is gonna not be able to deal with it. And that's why we often say that data drift is not a good proxy for model performance, because it might be that there's trends or seasonality, or that there is changes inside of the model, inside of the model input that the model has already seen before and actually knows how to deal with. So that's one problem, actually. And the thing with the traditional monitoring, why it doesn't help, is that important issues go undetected because there's such a strong focus on this covariate shift detection on the model input space. There's often complex structural changes that are ignored. For instance, concept drift or multivariate drift, and also data quality issues are largely mostly actually ignored in a traditional way of doing monitoring because we're so focused on these changes in the model input space. And of course, concept drift For those who know, it's when the relationship between the model inputs and the target changes. So this would be when from one period to another period, all of a sudden there is a fundamental change in how customers are interested in certain products, and that this pattern has not been observed in the past. That would be concept drift, and that is typically not necessarily tackled with the traditional monitoring algorithms. And that's why we say that important issues go undetected. Then there is another problem that important issues go unnoticed. So that they are being detected, but that somehow data scientists are not able to actually spot them properly and take action on them. And that's because with the traditional monitoring that focuses so much on data drift, there is lots of false alerts. For instance, here I have a screenshot where we see that there's so many drift happening. And it's actually, if you delve in deeper, drift that is not impacting the model performance. And then when you would investigate these alerts, you would actually realize that they are useless because the model knows how to deal with them. And that is something that's called alert fatigue. And if that happens a lot, data scientists will get desensitized. And when they get an alert, they'll say, yeah, it's not impacting model performance anyway, so I'm not going to bother. So that then when there is a real alert that's actually impacting model performance, it would get ignored and not investigated. And of course, the reason why there's so many alerts with these data drift is because specifically also in demand forecasting, this data drift detection, it is statistical tests that are repeated month over month, and they're just very sensitive. And so they will just every now and then say that there's changes, but they're not necessarily having an actual impact on the business. And then on top of these two problems, that unimportant issues go undetected and important issues go unnoticed, there is this whole problem of the availability of ground truth. I have a model performance chart here where you could see here where we have the performance during testing. We have here's the model gets deployed. We have the performance in production, and then we can see here that in the past 2 months we had performance issue. This is the moment that we're making new predictions. And when the ground truth is instant, we can create such a chart. Why? Because we have the targets and we can compare them to the predictions instantly. And maybe in e-commerce, when target data is instant, is when you make a recommendation for a product and a customer presses buy, it ends up in the basket and they pay for it. And then you can instantly calculate, was this a good recommendation? Because we know the customer bought it. And the time difference between that, it's only going to be a few minutes. And then we can create a chart like that. But unfortunately, with most machine learning use cases in production, the target is going to be delayed or completely absent. So then we would get only views like this. So at the moment that we're making new predictions, we only really know the performance of a few months ago, because for the latest months, we're still waiting for the target to be generated. Like, let's take, for instance, demand forecasting. If we are predicting for next week or for the next 3 months, we will only really know at the end of next week or at the end of those 3 months what the real demand was during that period. And it's only when we have the real demand that we can compare it to our predictions and get a view on the real performance. And then there's a few other scenarios that are, of course, making this thing a little bit more complex. And that's when the target data is partial, that maybe a part of it cannot be generated, or that it only gets generated very slowly and that it rolls in gradually, or that some of the targets are censored. Censored means that when we make a prediction and we take actions on the prediction, we're actually changing the reality. So for instance, if we're making a prediction that a product that we predict a certain demand for a product, and the product then runs out of stock because we didn't order enough, then of course the customers cannot buy that product, and it will then influence the real demand. And that is because we take an action of ordering the product based on the forecast, and that is then influencing the ability of what the real demand can still be. And that's when targets are censored. And when that's the case, it's also very hard to actually get a real notion of how performant our forecasts really are. And these three problems together, those are the ones that lead that AI models often fail silently. And what we mean by that is that only when the targets arrive after the damage, that the targets only arrive after the damage has been done, and that only when there is already a negative business impact can we observe model performance or the negative business impacts. So let me quickly guide you through this visualization here. If we have model inputs and based on those model inputs, we make a forecast, then on that forecast, we are going to take some type of business action. Maybe we do some promotions or we order. And then when there is a mismatch between these actions and actual reality, maybe we make an order based on the demand, but the customers are not interested in that product anymore. What will happen is that there is a mismatch, and that will then lead to a decreased business impact. But we can only really observe the decreased business impact either after it happened or when the actual targets arrive, when the sales data arrive and we get the actual demand. And then we can only measure the performance. But that's typically after the fact has happened, when it's too late and when we already lost the money. And then, of course, with demand forecasting, because it's such a complex use case, like what Nico already explained, we're really playing this entire game and these problems on hard mode. So there's trends and seasonality that are gonna mess everything up. There is these hierarchical levels that Nico already talked about, but also the machine learning models, they tend to be very advanced. So that means lots of modeling, lots of retraining. There's also always this trade-off between the look back periods, and trying to pick up new patterns, but trying to see which patterns are obsolete and then trying to pick up new patterns. And another thing is that the business value is also hard to calculate. And then there's this entire thing that we have to deal with other stakeholders as well. But of course, there's a solution, and that's to do post-deployment data science and to do post-deployment data science well. And we see a big trend that today in the world, there's more and more models getting deployed, and that there is also more and more focus on maintaining these models and keeping these model performance. So we see the future of data science, it being post-deployment. And as you would join companies in the future is not so much about, okay, which new AI do we have to build? It's more going to be about, okay, how can we improve the existing algorithms and the existing systems to deliver more value or to at least bring the value that they have been bringing before. And how do we do post-deployment data science with NanoML? Is that we've developed algorithms, and what these algorithms do is they try to quantify the impact of the data drift that they have on the model performance and the business value. And basically these algorithms, they try to estimate model performance when there is no target data yet, so that we can always get a view on how the model is performing. And then we don't use the drift detection algorithms that are measuring the changes in the model input as an alerting mechanism, but as a root cause analysis tool. So what we do here is we look at the main performance metric, and when this main performance metric deteriorates, this is the expected performance, so not the real performance. The expected performance is already available at the moment that you're making predictions. And when this expected performance drops underneath a threshold, then we can leverage the other tools to kind of figure out what's going wrong. Oops. And then, of course, we also have developed some other algorithms to detect more complex changes like multivariate data drift and concept drift, and some advanced data quality tooling is on the way. And what this allows us to do is to develop a performance-first monitoring tool. And what Nico already said a little bit earlier is, yeah, I don't care about the data drift and I don't care about the concept drift. And that's exactly what this performance-first monitoring tool is about, is that we focus on model performance. And that basically we don't have to go and look deeper in all of those data drift alerts, only when there is an actual issue with the model performance. And when there is, then we can leverage, or the data scientist can do a more granular analysis and kind of figure out what type of changes in the data led to the model not performing, and figure out the best remediation action. And just to explain some intuition in how these algorithms work to estimate model performance, I have here just a very simple variable, which is x variable, and then y we could consider, for instance, the demand. And if you look at this chart, you can actually, and we fit it here, just a very simple linear regression model. But what we could see here is that actually based on the region of X of the feature, we can derive how many mistakes or how performant our model is going to be. Because if we see here at 0, there's lots of mistakes and lots of variance. And when feature X is higher, the model becomes actually more accurate. And we can see that when we calculate some type of rolling mean, that in the beginning we have very high errors, and here we have very low errors. And that is the type of intuition that we're going to be leveraging in our performance estimation algorithms. That there are certain regions in the feature space where the model is just more or less performant. And how this is a 2D visualization that basically explains the same concept. So imagine that we are able to extract some type of estimated loss landscape or some uncertainty map inside of during testing. And then we can kind of see where in this feature space the model is very performant and where it's not. And then when in production, there is new observations appearing for which we have the model input, so we know where in this feature space they appear. We can then get an idea of what the expected error is. And then, for instance, if you go to production and it's completely different and there is more of these observations appearing around the sites where there is lots of expected error, we can then know that the model is becoming less performant. And that's type of the intuition that we leverage inside of our performance estimation algorithms. And what that allows us to do is that at the moment that we're gathering all of the data to make our forecast, we can actually already get a view based on these model inputs of what the actual expected performance is going to be. And if this expected performance is less, or there's something wrong with that, then we can start taking some remediation action and prevent the actual bad predictions from having negative business impact and preventing the model failure. So this is all about trying to detect as fast as possible when our forecasts are potentially not up to par or will have a negative business impact. And it's these algorithms that allow that to do us. And then, of course, what's there specifically for demand forecasting to take in mind? That's, of course, drift detection when there's trends and seasonality, because in general, the drift detection algorithms, they don't necessarily work very well when there is just an monotonically increasing trend, for instance. So what we'll do there is to either remove some of the trend and the seasonality and work on stationary data. We can use segmentation to deal with different hierarchical levels in the forecast. And then there's ways to quantify the business value by specifying custom metrics. And this is actually what I wanted to come back to that one question that we got before. What's the best machine learning model performance evaluation metric? Post-deployment, it's for sure, so not necessarily when testing, it's for sure a metric that is as close as possible to the real value. And if there is a way to quantify the real value by leveraging margins or by leveraging profit, then that is potentially the optimal way to do it. And it's also, if you can do it, then that is ideally the metric that you communicate to the business stakeholders. Because if you explain that your model is making less money than before, it is something easy to internalize. And a side benefit, actually two side benefits of this expected performance algorithm is that it allows you to only retrain them when necessary, when the expected performance is deteriorating, and that you can communicate a single expected performance metric to the other stakeholders. So again, that you don't have to get lost in all of the little details that have to do with drift detection and changes in the data. I'm quickly gonna skip this slide and just show you 5 minutes on how this entire solution of NanoML comes together in a quick demo. So we're available on the cloud marketplace where you can search for NanoML, either on Azure, AWS. We also deploy in Google Cloud. And then you can get NanoML monitoring platform running inside of your cloud environment so that there is actually no data being sent to us. And then how to connect to the NanoML instance would be by installing a Python SDK, connecting to the instance. Then we can load some data. I got some regression data here where we use the reference data, which is basically the test set where we know how the model is behaving as expected. We get the predictions in production together with the model inputs, but the target data is not generated yet. And then we do a quick mapping to tell NanoML, okay, what is exactly in this data set? And then we can send it to the monitoring platform. And then inside of the monitoring platform, if I quickly refresh, we'll see that there's going to be a new model being added in production. There's already lots of models here. And it's this one, it's a regression model. And while NanoML is quickly crunching these numbers, I'll explain here what we see in this main model monitoring dashboard. So here we have what we actually do. There is these use cases. Some of them have real performance because the targets are instantly available, but others don't. So here we use these performance estimation algorithms to get a view on the expected performance. So that is the main thing, that we can always know how these models are expected to perform, expressed in a performance metric or a business value metric. And then we can see here actually that lots of these use cases have changes in the data, but this data drift is actually not impacting model performance. So these data drift issues right now, we won't have to investigate because we already know, because of the performance estimation algorithms, that they're actually not impacting performance in a negative way. So this is a way to reduce alert fatigue, is to use this performance estimation algorithms. Let me quickly see. In the meantime, this algorithm has finished running. And here we can see the mean absolute error on the test set, and the model got deployed here. But then for these few days, we actually don't know how this model is performing because the target data is not generated. So what we can do then is to use and leverage our performance estimation algorithms that then create an actual view on what the expected performance is. And then we can see here in these last few days that there is an actual issue with the mean absolute error and that it's going up. So that then will warrant an investigation. And this is a metric that can be communicated if your business stakeholders, of course, understand mean absolute error. Else you can transform this metric to a metric that is more related to dollars or more related to business value. But right now, then data scientists that understand the model, understand the business, and understand the context in which the model is operating, then they can kind of go and analyze all of the features and what's going on. And what we can quickly do here is actually pick the average and then only show those features that have an alert. And then we can see here, for instance, this feature has an alert here in this last month where there was an issue in this last day. And then this other feature actually also has an issue here, the period before and the period that. And it's maybe these three data points combined that have actually had a negative impact on the mean absolute error, because we see that the root mean square error is actually not impacted with here. And that's kind of the root cause analysis that then data scientists will have to go through. And that's a quick demo of how all of these different concepts come together and how NanoML can create a view on the expected performance so that you can act faster and act sooner and prevent models from actually having deteriorated and negative business impact. Okay, I've seen that there are some okay. Someone asked, sorry, I don't really figured out how we use ROC AUC for time series forecasting metric. That was just an illustration. I wouldn't use ROC AUC, or I cannot think about a scenario on how to leverage ROC AUC for a good forecasting metric. It was just to demonstrate that some of these metrics cannot be generated when there is no target data and how that kind of would look. So that's indeed from a classification use case. What platform would you recommend to use while experimenting with different models to manage all models efficiently? Maybe that's a good question for you, Nico. Um, what platform are you guys using to experiment with your models and to manage them from an MLOps perspective?
On the maps, yeah, we're running everything on Databricks. Allee, the fact that we have all our models, so we use Azure, we use Databricks as a compute. We use our GitHub for the versioning. We have Terraform for a CI/CD pipeline. So that's a bit how we industrialize our models, if that is the answer to your question, of course.
Yeah, I think there's of course some experimentation frameworks as well. Like MLflow itself, I think is a good one to run some experiments.
Yeah, that's also what we
Um,
use indeed for experimentation, indeed, to keep track of your metrics, indeed, metrics.
yeah,
Uh,
we've actually also developed some tooling to do experiments, but specifically experiments post-deployment when the model is already deployed in production. Because sometimes what you have, for instance, if you have a model inside of a warehouse of inside of a factory, if you update or change the model, it might be that you influence the actual business process. So then what you can do is to do it either in one distribution center first or on one machine or in one production line and then kind of gather information of what, first of all, the performance is, but also the expected business impact because the business process is changing. And then when you gather that information in a pilot where the model is already deployed in the real world, you can kind of reliably try to gather information. What happens if you scale that up? If you roll this out to all of the other distribution centra or if you to machines or production lines, are we going to be holding this model performance? Can we make certain guarantees against that? And can we also make certain guarantees with the process or the product quality? So we also have developed some tooling about it, but this is tooling post-deployment again. Um, so I hope that answered your question. Then we have another question here. Marco Cunha from Fisher Connectors. Any use case connected with SAP on the industrial environment? Um, I will just try to maybe answer that in general, and then maybe you can explain what you exactly mean with an industrial environment. But in general, how our monitoring platform works, and actually one of the reasons why we as a company also decided to build monitoring is if you look at a machine learning model, there's always data coming in and there's always data coming out. And that is very, very scalable. And all of the data science practices, they're typically very different from one company to another. But this paradigm of a machine learning model with input and output is always the same. So what we do is we hook up to the model input and the model output, and then everything else inside of our platform just works. So we're model agnostic, we're framework agnostic, we're becoming data type agnostic because we're adding more and more different data types. So it doesn't necessarily really matter what type of platform you're using to deploy your models or where your models are running. The only thing that actually needs to get caught is what goes in and what comes out of the model. And then maybe later downstream the targets when they are generated.
yeah, maybe feedback from me, William, also have. So we have some models running for SAP, but what we do, we extract the data from SAP into our Azure platform. So these data pipelines need to be built, and then we do all the modeling on our Azure platform, and then the output we send back to SAP. So that's a bit the strategy also within our company. All the analytics, all the data science is done on Azure. So if you want to do, if you want to build a model, if you want to do analytics, you need to get the data there. So if you have a data lake where a lot of applications are already inserting that data. And if you want the insights in a certain application, we need to push that then later on, but everything is done on our Azure platform.
Yeah, that makes sense. That a little bit the same paradigm actually.
Yeah, indeed.
Uh, I got another question. We're using from Xavier. I'm part of PepsiCo forecast data science team. We're using many models with granularity on product code, customer location, far over 1K models. Could we still leverage NanoML? Yeah, so that's a very, very good question, because I also already mentioned earlier that in demand forecasting, because of these different hierarchical levels, there's typically lots of machine learning models that are being built, and they're doing lots of stuff in parallel. So there's two dedicated features that we have for this specific problem. And first of all is that for all of these different models, you kind of want to aggregate model performance in a meaningful way. So that means that you want to either weight them in terms of how important these models are, maybe for margin or revenue. And then the key thing is to identify for all of those models, which models are exactly underperforming and why. So the way to go about that is then to actually isolate those models that have issues, performance issues, and then to drill down for those specific models um, to figure out why they're failing, and then also to remediate that. And one of these things that really helps for when you have lots of models in production is that sometimes these models are also on the same retraining schedule, whereas different products often actually do not have the same volatility in demand. If you look, for instance, at electronics, maybe they are actually way more stable, and how people buy electronics is actually not that much influenced by seasonality or trends, or by new patterns that emerge from a day-to-day basis. And then these models you kind of want to put on a different retraining schedule, because the demand is generally stable over time. Then there is, of course, other products that maybe are actually super volatile in terms of how customers are buying them, and then these models you might want to put on a very short retraining schedule. So these are type of the three things that we leverage in our platform. So it's the multi-model support, aggregating to a meaningful performance metric globally across all of these models, and then also trying to find underperforming models, and then just following kind of the monitoring flow that I quickly explained in the platform, but also finding the ideal moment to potentially retrain for these models. I hope that answered your question a bit, Xavier. But happy to jump on a call after to delve into detail a little bit more and see how you guys work. I think Nico, you guys also leverage lots of different machine learning models inside of your demand forecasting system, right?
Yeah, because we have I think we have 100 different models for the e-commerce demand forecasting scope indeed. So that's a lot indeed.
Okay, great. I think those were all the questions, and we're also nearing the end of this webinar. So thank you so much, everyone, for joining. Also, Nico, thank you so much for elaborating on the demand forecasting use case and kind of setting the stage for a post-deployment data science world. It was a pleasure having you.
Thank you, William. It was a pleasure being here.
Thank you. See you next time.